now we want to take a look at how we can essentially cancel out these sine, cosine, tangent functions with their inverse functions by composing them. And but first, we want to take a look at the restrictions we have when we're using sine to undo the inverse sine of x. And the same goes for cosine. Uh, we have to make sure that x is within the bounds of -1 and 1. Tangent, taking the tangent of the inverse tangent of x will yield to x no matter what the x value is. For the opposite, taking the inverse sine of sine, we've mentioned this before, that it has to be essentially on the right side of the y-axis from -pi/2 to pi/2. X has to be above the x-axis when we're taking the inverse cosine of x. And then we have the same bounds as inverse sine when we're looking at tangent. So those are actually straight out of your book if you ever need to access them in section 4.6. So let's look at this example here. Find the exact value of sine of arcsine of 1/2. Well, by just simply using the inverse, this is pretty simple. Sine and arcsine cancel each other out. So we're left with 1/2. We just have to make sure that that's within the bounds. And when we look at taking the sine of the arcsine, which is this here, 1/2 is indeed within -1 and +1. So we can be confident that our answer is 1/2. Now looking at the inverse cosine of 5pi/2, the theoretical value would be 5pi/2. Let's make sure that's within the bounds. We have cosine -1 of cosine x, between 0 and pi. Unfortunately, 5pi/2 is not between 0 and pi. It's about 2.5 pi. So a little beyond 2 pi, a little past the full circle. So it is technically in that first quadrant if we think of it as another angle. If I'm drawing up my axes in terms of pi/2s, we've got 1 pi/2, 2 pi/2, 3 pi/2, 4 pi/2, back to 5 pi/2. So really 5 pi/2 is the same thing as pi/2. So that's got to be my answer since that's within the region allowed for this process. So finally, let's look at the arctan of tangent of -5 pi/2. Again, if it's within the bounds, that's easy. It's 5 pi/2. Going back, we're looking at arctan of tan. So it's got to be between -pi/2 and +pi/2. Thinking of our axes, if we go backwards, we've got 1 pi/2, -1 pi/2, -2, 3, 4. We're here for -5 pi/2, so it's the same thing as -pi/2. Unfortunately, for tangent, it looks like that's right outside the bounds. X has to be greater than -pi/2, so therefore this actually does not exist. And you'll get some like that. So go ahead and see if you can figure out the exact value of the arcsine of sine of 7 pi/6.